How long would it take us to go to Mercury? The smallest planet of the solar system is a very unique planet and holds answers to a lot of questions about our solar system and its evolution. Thus, exploration of Mercury is important for a number of reasons. As the closest planet to the Sun, it is a unique celestial body that can provide valuable insights into the early history of our solar system. One of the key reasons for exploring Mercury is to learn more about its surface and atmosphere. Despite being the smallest planet in our solar system, Mercury has a unique surface that is heavily cratered and has evidence of past volcanic activity. Studying this surface can provide valuable information on the early history of our solar system and the processes that shaped it. Another reason for exploring Mercury is to study its magnetic field. Despite its small size, it has a surprisingly strong magnetic field that is similar in strength to Earth's. This magnetic field is thought to be generated by the planet's core, which is composed of molten iron. Studying this magnetic field can provide valuable insights into the structure and composition of the planet's interior. Exploring Mercury is also important for understanding its potential for hosting life. While the surface conditions on Mercury are extreme, there is evidence to suggest that the planet may have had liquid water on its surface in the past. If this is the case, it's possible that conditions on the planet may have been suitable for the emergence of life. Studying the potential for life on Mercury can provide valuable insights into the potential for life elsewhere in the universe. Overall exploration of Mercury is important for understanding the early history of our solar system, the processes that shaped it, and the potential for life on other planets. By studying this fascinating planet, we can continue to unlock the mysteries of our universe and expand our knowledge of the cosmos. In order to continue the exploration, we need to reach the planet first. To answer the question of how long it would take us to go to Mercury, we need to consider a lot of factors like speed, distance, propulsion systems, etc. The discussions that we will make would be based upon the current level of technology that humanity possesses. The first factor to consider would be the speed at which we would be traveling. The fastest spacecraft ever launched was the Parker Solar Probe, which reached speeds of up to 430,000 kilometers per hour. However, even at this speed, it would still take us over 4 months to reach Mercury. And that is the case at the fastest speeds and considering Mercury is closest to us. How far is it from Earth usually? Let's talk about that first. We all know planets follow an elliptical orbit. All the planets follow their orbits, and because of this type, distances between them might vary. They might be closest at a certain point of time, and they might be farthest too. So there is no one distance between Earth and Mercury. Mercury's closest approach to Earth is 28.6 million miles, while its greatest distance from Earth is 43.4 million miles. Mercury's eccentric orbit causes this wide difference between the nearest and furthest distances. It has the most eccentric orbit in our solar system, with an eccentricity of 0.21. With an eccentricity of 0.06, Venus has the least eccentric orbit. There are instances when Mercury is behind the Sun, resulting in a Mercury, Sun, and Earth alignment. The Sun will be in between Earth and Mercury. Mercury is now about 138 million kilometers from the Earth. The furthest it can get is 222 million kilometers. Mercury's closest approach to Earth happens when both planets are on the same side of the Sun, a phenomenon known as inferior conjunction. Mercury is now positioned between our Sun and Earth, shortening the distance between the two planets to about 28.6 million miles or 46 million kilometers. There have been several previous missions that have been sent to the first planet in our solar system. While it may take us several months to reach Mercury using current technology, there have been several previous missions that have been sent to the planet. The first mission to Mercury was the Mariner 10 spacecraft, which was launched by NASA in 1973. The Mariner 10 mission took a total of 6 months to reach the first planet, with the spacecraft using a gravitational slingshot with Venus to accelerate its journey. Once it reached Mercury, the spacecraft conducted several flybys of the planet, gathering data on its surface and atmosphere. Another mission to Mercury was the Messenger spacecraft, which was launched by NASA in 2004. This mission took a total of 6.5 years to reach Mercury, with the spacecraft using multiple gravitational slingshots with Earth and Venus to accelerate its journey. Once it reached Mercury, the Messenger spacecraft entered into orbit around the planet, conducting detailed studies of its surface and atmosphere. This mission lasted for over 4 years before the spacecraft ran out of fuel and crashed into the planet's surface. More recently, the Bepi-Colombo mission was launched by the European Space Agency and the Japan Aerospace Exploration Agency in 2018. This mission is currently on its way to Mercury with an expected arrival date in 2025. The spacecraft is using a combination of solar electric propulsion and gravitational slingshots with Earth, Venus, and Mercury itself to reach its destination. Overall, previous missions to Mercury have taken several months to several years to reach the planet, depending on factors like route and technology used. These missions have provided valuable information on the planet's surface and atmosphere, and have laid the groundwork for future missions to explore this challenging destination. But if you think carefully, the previous missions and the time taken in them differs drastically. Although Earth is 10 times closer to Mercury than Jupiter, missions to both planets can take roughly the same length of time to reach their scientific orbits. Why is this the case? NASA's Mariner 10 spacecraft took only 147 days to reach the innermost planet of the solar system in the 1970s. However, more recent missions, like as NASA's Messenger in the late 2000s and the European-Japanese Bepi-Colombo launched in 2018, will take years to reach Mercury. The reason for this is that they are not on the same route. Messenger and Bepi-Colombo were meant to enter orbit around the planet and perform more extensive scientific research over a longer period of time, whereas Mariner 10 conducted 3 flybys of Mercury while in orbit around the Sun, offering our first up-close glimpse of its surface. To enter orbit around Mercury, the spacecraft must move slowly enough relative to the planet's velocity to be trapped by its gravity. They must slow down from their original speed, which is rather challenging in the vacuum of space. In order to reduce the time taken by a spacecraft to reach Mercury, we can use a method called gravitational slingshot. This involves using the gravitational pull of another planet such as Earth or Venus to accelerate the spacecraft and reduce the time it takes to reach its destination. For example, if we were to use a gravitational slingshot with Earth, it would take us just over 2 months to reach Mercury. However, this method also has its drawbacks, as the spacecraft would need to be carefully maneuvered to avoid colliding with the planet it's using for the slingshot. Another factor to consider is the time it would take for the spacecraft to land on the surface of Mercury. Unlike Earth, Mercury has no atmosphere, which means that the spacecraft would need to use its own propulsion systems to slow down and land on the planet's surface. This could add additional time to the overall journey. Once we've landed on the surface of Mercury, we would need to consider the time it would take to conduct any scientific experiments or research on the planet. Due to the extreme temperatures on Mercury, any missions would need to be carefully planned and carried out quickly to avoid damaging the spacecraft or the equipment on board. Overall, the time it would take us to go to Mercury would depend on a variety of factors, including the speed of the spacecraft, the use of gravitational slingshots, and the time needed for landing and conducting experiments on the planet's surface. However, even with the fastest spacecraft and the most efficient route, it would still take us several months to reach Mercury and carry out any necessary research. How long would it take us to go to Venus? Venus is the brightest planet in our sky. In fact, it's just in the list of brightest objects after the Sun and the Moon. Also known as a twin of our planet Earth, exploration of Venus has been one of the most important planetary objectives after Mars. Humanity has sent many missions to the morning star, but the mysteries around the planet are still to be answered. And to answer those questions, we need to first go there. It's full of scientific marvels, such as being the hottest planet in our solar system and having 92 times the surface pressure of Earth. We have sent several unmanned expeditions to Venus, but we have yet to set foot on its surface. When considering an accomplishment like this, there are several elements to consider. The Sun is the brightest object in our sky because it is a huge ball of fire,
The moon is bright because it is incredibly close and reflects the light from the sun. But Venus is bright for two main reasons: its highly reflective atmosphere and its very close distance to Earth. So what is the distance of Venus from Earth? Let's talk about that first. We all know planets follow an elliptical orbit. All the planets follow their orbits, and because of this type, distances between them might vary. They might be closest at a certain point of time, and they might be farthest too. So there is no one distance between Earth and Venus. You will observe Venus to be on the opposite side of the Sun from us when it reaches superior conjunction. The largest distance between the two planets is when the Earth is at the extreme end of its orbital ellipse. In the same manner, they are closest to each other at the inferior conjunction, which happens every 584 days. This is the point at which Earth, Venus, and the Sun all align, with Venus and Earth on opposite sides of the Sun. The closest Venus can get to Earth is when it passes through the least curved region of Earth's orbit. This occurs when the Earth is close to perihelion, its closest approach to the Sun. The orbits of both the planets are mathematically linked and repeat almost perfectly at every 5 conjunctions, which last for around 8 years. This indicates that the distance between Earth and Venus at each conjunction will be roughly the same after 5 conjunctions. With all this information under our belt, we know that there is no one answer to the question of how far away is Venus, but we do know its closest, farthest, and average distance from us. As we mentioned above, all planets orbit in an ellipse rather than a circle, but Venus has the most circular orbit. The average distance between the planet and the Sun is 67 million miles, or 108 million kilometers. Venus is closest to Earth at its inferior conjunction, where it is just 25 million miles, or 40 million kilometers distant at its closest, perihelion. Because of changes in Earth's orbit throughout time, the minimum distance between our two planets has risen. Since 1623, Venus has been no closer to Earth than 24.5 million miles, or 39.5 million kilometers. Venus will not approach within 24.8 million miles, or 40 million kilometers of Earth for more than 60,000 years after the year 5683. Venus's closest and farthest approaches occur only every 19 months or so. Between times, its average distance from Earth is around 42.2 million miles, or 68 million kilometers. This isn't the whole story, because the distance to Venus changes every day and fluctuates greatly over each orbit. But it's a good starting point. Venus is even closer to Earth than Mars. Scientists today think that Venus had habitable conditions a few billion years ago, until a runaway greenhouse effect caused by volcanic activity and water loss from Venus's atmosphere. This process sentenced Venus to its current terrible landscape. Because of many reasons and mysteries like this, the morning star has been a prominent target for space missions. With the first space missions launched by Soviets and Americans in the early space race in the 1960s, both the countries sent various spacecraft to the hellish planet in the space race. Out of the 41 missions launched to Venus since the advent of the space era, 23, American and Soviet, have successfully traveled to Venus, counting all of those that flew past Venus without being dedicated to studying it. This success rate easily exceeds the success rate of missions to Mars. These spacecraft, which have been sent to Venus, can offer valuable insights on how much time it takes to reach it. The Venera 1 spacecraft by the Soviet Union was the first space probe to be launched towards Venus. The mission was launched on February 12, 1961, with the primary goal of reaching the planet. However, on February 17th, scientists lost touch with the space probe. Because mission controllers did not have time to make a course correction that would have brought it closer to Venus, it is believed to have passed within 100,000 kilometers of the planet on May 19th. That's a total of 97 days, or a little more than 3 months. NASA's Mariner 2 completed the first successful Venus flyby. This spacecraft was launched on August 8, 1962, and successfully completed a flyby on December 14, 1962. So the total time from launch to arrival at Venus is 110 days. The Pioneer Venus 1 mission was launched on May 20, 1978, and arrived at its destination in 198 days. ESA's Venus Express was the most recent spacecraft to visit Venus. It was launched on November 9, 2005 and traveled to Venus in 153 days. Why is there such a difference between the time taken by different spacecraft? Traveling to the planet in a spacecraft is not an easy task. It's not feasible to simply determine its location, point a spacecraft at it, and click the huge launch button. Instead, we must account for the movement of the planets as they orbit the Sun. We must also avoid our own gravitational pull at the beginning of our voyage and enter Venus's at the finish. It all comes down to several factors like the route, fuel efficiency, and others. Let's take a look at some of these. All of this is like a physics ballet. Often the best path to our destination is not the most direct, which adds to the time it takes to get there. It all boils down to launch velocity and trajectory. The Earth and Venus are both in orbits around the Sun. In order to reach the morning star, you must travel in a transfer orbit between Earth's orbit and Venus's orbit, catching up with Venus and ideally entering orbit. To accomplish the journey with a smaller, less costly rocket, you must take a longer, more time-consuming route. Another important factor to consider is the sort of engine driving the spacecraft, whether it is fuel efficient or not. And a third factor to consider is that slowing down takes a long time. So if a spacecraft is only going to fly by, it must slow down. But if it's going to orbit, its voyage to Venus will take longer. So because of this, it is very clear that there is no one answer for how long it would take to reach Venus. It all depends on a variety of factors, but based on the history of missions to Jupiter, the shortest time a spacecraft took was 109 days, and the longest was 198 days. On an average, missions to Jupiter take between 120 to 135 days. But what about humans going to Venus? Terraforming it has been an important topic for discussion lately. If Venus was once habitable, could it be made habitable again? To be honest, the process would be really hard because of the planet's hellish atmosphere, but certain ways can allow the terraforming of Venus. But that's a topic for another video. Today we want to talk about whether a human mission to Venus would be possible. Humans have never made the trip, but someday we can expect at least a flyby mission, as landing on the planet itself would be very unpleasant. The only probes that landed safely on Venus and sent back images of its surface area were Venera 9 and Venera 10, which lasted for 53 minutes and 65 minutes respectively. The surface temperature of Venus can reach up to 950 degrees Fahrenheit, not to mention thousands of volcanoes and a planet like an oven. Simply surviving on Venus's surface would necessitate technology that could endure tremendous heat and corrosion from sulfuric acid in the atmosphere, not to mention the strain on the human body. Humanity will send several unmanned expeditions to the planet. Even so, machines can only retrieve so much data and information. We'll arrive at a moment in time when our next move will be to set foot on the planet. There are a few basic properties of Venus that fascinate astronomers all around the world. The fact that there is a layer of atmosphere in which humanity may exist, and that the planet's rocky surface is similar to Earth's. We can just imagine what a human landing on Venus would look like. On an average, with the best of our spacecrafts, we can even shorten the journey to 60 to 80 days in the future with better engines and propulsion systems. But only time will tell. How long will it take us to go to Mars? And can we decrease that time with technological advancements? The answer is a big yes. How? When it comes to Mars, though, there's a reason why we haven't explored the Red Planet and why only a few landers have made the trip. There are many problems lying in the deep depths of space that make a voyage to Mars oh so tough. The journey to Mars has been the stuff of science fiction for generations, but now it is quickly becoming a reality. There are many challenges that need to be overcome before a crewed mission to Mars can be launched, but the two major players, NASA and SpaceX, are up to the task. They have been working together intimately on missions to the International Space Station, but they have competing ideas of what a crewed Mars mission would look like. NASA's focus is on safety and caution, while SpaceX is more innovative and willing to take risks. However, both organizations recognize the need for cooperation in order to make a journey to Mars a success. By pooling their resources and expertise, NASA and SpaceX might be able to overcome any challenges standing in the way of the journey to Mars. In order to determine how long it will take to reach Mars, we must first know the distance between the two planets. Mars is the fourth planet from the Sun and the second closest to Earth. Venus is the closest. But the distance between Earth and Mars is constantly changing as they travel around the Sun. In theory, the closest that Earth and Mars would approach each other would be when Mars is at its closest point to the Sun, perihelion, and Earth is at its farthest, aphelion. This would put the planets only 33.9 million miles or 54.6 million kilometers apart. However, this has never happened in recorded history. The closest recorded approach of the two planets occurred in 2003, when they were only 34.8 million miles or 56 million kilometers apart. As such, the journey to Mars would likely take anywhere from 33 to 34 million miles. How long would it take to reach Mars if you were traveling at the speed of light? It would take 3.03 minutes to reach Mars at its closest point of approach to Earth, and 22.4 minutes to reach Mars at its farthest point from Earth. The average distance between Earth and Mars is 65.4 million kilometers, so it would take 12.5 minutes to reach Mars traveling at the speed of light in a vacuum. These numbers are based on the assumption that you are starting from Earth and traveling in a straight line towards Mars. In reality, the journey would be much longer because you would need to account for the curvature of the Earth, the rotation of the Earth, and the orbit of Mars around the Sun. However, even with these factors taken into account, it would still be possible to reach Mars within an hour if you were traveling at the speed of light. But traveling at the speed of light is not a realistic approach for us, at least according to our current technologies. But what about the fastest spacecrafts that humanity has ever built? NASA's New Horizons spacecraft is one of the fastest ever spacecraft to travel to the outer solar system, capable of reaching speeds of around 36,000 miles per hour or 58,000 kilometers per hour. If you could use such a spacecraft to travel to Mars, you would reach the planet in just 162 days or 3,888 hours at its average distance from Earth. However, at its farthest point from us, Mars would be 289 days, 6,944 hours away. But things get even better when Mars is at its closest possible approach to Earth, as you would then be able to reach the red planet in just 39 days or 942 hours. But last year in 2021, even this record was broken by NASA's Parker Solar, which was shattering its own speed records as it gets closer to the Sun. On November 21, 2021, the Parker Solar Probe attained a peak speed of 101 miles or 163 kilometers per second during its 10th close flyby of our star, equating to 364,621 miles per hour or 586,000 kilometers per hour. According to a NASA statement, when the Parker Solar Probe approaches the solar surface in December of 2024, the spacecraft's speed will exceed 430,000 miles per hour. With the speed of the Parker Solar Probe, it would take us just 93 hours to reach Mars at its closest approach, and just 29 days on its farthest distance from the Earth. That's a big thing for humanity. The difficulty with the previous estimates we talked about is that they use a straight line to calculate the distance between the two planets. Traveling through the furthest passage between Earth and Mars would require a travel directly through the Sun, whereas spacecraft must move in orbit around the star of the solar system. Although this is not a problem at the closest approach, another issue arises when the planets are on the same side of the Sun. The figures also assume that the two planets maintain a constant distance. That is, if a probe is launched from Earth while the two planets are at their closest approach, Mars will stay the same distance away for the duration of the probe's 39-day journey. How long it takes to reach Mars depends on a number of factors, including the planet's alignment in their orbits and the propulsion system used. According to NASA's Goddard Space Flight Center, the ideal lineup for a launch to Mars would get you to the planet in 9 months. However, due to the positioning of the planets and other factors, it is usually closer to 2 years. Engineers must calculate the ideal orbits for sending a spacecraft from Earth to Mars. Their numbers factor in not only distance, but also fuel efficiency. Like throwing a dart at a moving target, they must calculate where the planet will be when the spacecraft arrives, not where it is when it leaves Earth. Spaceships must also decelerate to enter orbit around the new planet to avoid overshooting it. How long it takes to reach Mars depends on where in their orbits the two planets lie when a mission is launched, and also on the technological developments of propulsion systems. Mars moves a significant distance around its orbit in the 9 months it takes to reach there, roughly 3/8 of the way around the Sun. You must prepare ahead of time to ensure that Mars is where you need it to be by the time you reach the distance of Mars's orbit. In practice, this implies that you can only begin your journey after Earth and Mars are correctly aligned. This happens once every 26 months. That is, every 26 months, there is just one launch window. The Hohmann transfer technique, with launch windows every 26 months, is the quickest and most efficient way we know for reaching Mars, and it takes around 9 months to accomplish. A round trip would take about 21 months to complete. We would need to spend thousands of dollars a second to just get to the red planet, and would have to sacrifice a large amount of payload based upon our current technology, and not to mention the kind of impact such a long trip would have upon human psychology. So if we are able to achieve speeds like the Parker Solar Probe, a journey to Mars would be much less than it is right now. But what is humanity doing right now to try to get to Mars? Elon Musk, the CEO of SpaceX and one of the first pioneers to go to Mars, is creating the Starship to transport humans to Mars. SpaceX is presently developing their Raptor engines, which are recognized for producing a tremendous level of thrust. They want to replace it with the Raptor 2.0, which will be a significant upgrade in Raptor engines. But what distinguishes SpaceX is its quick reusability, which no other firm has done as of yet. The Raptor 2 engine, which is presently in development, is an important component of SpaceX's future. It has a massive amount of power that has been nurtured in ways never previously seen with science and reusability. The Raptor engine is something that space engineers have long desired but have never been able to achieve. It will save money, energy, and allow enormous spacecraft like the Starship to bypass our atmosphere and sail directly for Mars.